Okay, hi. This is a 2017 PHSS MYE paper. Okay, so first question, you have a mixture of hexane and heptane. The boiling point for both substances are given to you. So, which graph will be obtained if the total volume of distillate collected was plotted against the temperature at point T? So you need to know that at 70 degrees Celsius, what happened? The hexane is collected. Okay, hexane is collected, and then which means what? Which means that your distillate, the volume of the distillate will increase. Volume of distillate will increase. Then after that, how about after 70 degrees Celsius, or between 70 degrees Celsius and 98 degrees Celsius? What happened to the volume? So this one, no substance would be distilled over. So which means that at this point, or in between these two temperature, the volume of distillate basically is constant, doesn't increase. Then after that, at 98 degrees Celsius, heptane will be obtained, which means that the volume of distillate will go up again, will increase again. Okay, so at 70 degrees Celsius, increase. In between 70 to 98 degrees Celsius, constant. At 98 degrees Celsius, increase again. So the answer is C. Okay, at 78 degrees Celsius, volume increases. Then after that, in between 70 and 98 degrees Celsius, okay, so this one is here is roughly 98 degrees Celsius, the volume stay constant. Okay, this is a volume. Then after that, at 98 degrees Celsius, it increases again. Then after that, stay constant again. Question 2. Which statement is not correct? Large increase. There is a large increase in volume of the solid metal when the pressure is applied. Well, you should know that pressure has no effect on the solid, because solid is incompressible. Solid is incompressible. So the volume of the solid should not decrease when you apply pressure. So not correct, it is D. Okay, number 3, which substance is most likely to be an element? First statement, burns in air to form carbon dioxide and water. So write down, so this substance, okay, it burns in air, meaning that it combines with oxygen, and then it will form carbon dioxide and water. So this oxygen come from here. How about the carbon and the hydrogen? Carbon and hydrogen should come from here, which means that this substance is not an element, it is a compound. Okay, so statement 8 is wrong. How about for B? It conducts electricity as a solid and also when in molten state. Can conduct electricity in solid and molten state. An example would be metal. Metal can conduct electricity in a solid state. Molten state also. Okay, because of the delocalized electrons. So which means that most likely to be an element, metal, all metals are elements. So the answer is B. Okay, how about now the next question? Rate of diffusion was compared at 25 degrees Celsius and 50 degrees Celsius. Which would have the fastest rate of diffusion? So you should know that, you should try to recall that rate of diffusion depends on temperature as well as the molecular mass. Higher the temperature, slower will be the rate of diffusion, and lower the molecular mass, faster would be the rate of diffusion. Okay, so if I want the fastest rate of diffusion, I should, higher the temperature, faster would be the rate of diffusion. Okay, Higher temperature, faster. Lower molecular mass, faster the rate of diffusion. So if I want fastest rate of diffusion, it should be higher temperature, lower molecular mass. Which means that lower molecular mass would be X, higher temperature would be 50 degrees Celsius. So there will be X and 50 degrees Celsius. Answer is B. Okay, number 5, you want to prepare and collect dry sulfur dioxide. So which change would make the experiment successful? So this one is not successful, no good. So what do I need to change this experimental setup in order to make the collection successful? You have sulfur dioxide. First of all, sulfur dioxide, it is an acidic gas. So sulfur dioxide is produced here. Then after that, it is bubbled into potassium hydroxide, KOH. KOH, you should know that group 1 hydroxide, like lithium hydroxide, sodium hydroxide, all these are alkali. Group 1 hydroxides, they are all alkali. Okay, group 1 hydroxides, they are all alkali. So which means that when an acidic gas is bubbled into an alkali solution, that means neutralization will occur. Neutralization occur. So what will be obtained here? Neutralization, you should get salt and water. So there will not be any more gas coming out here. So which means that the changer would be to remove this flask. So omitting flask P containing aqueous sodium hydroxide, potassium hydroxide. So it is A is the answer. Number 6, two particles X and Y have the structures shown. Which term describes X and Y? So X and Y, so first of all, same number of proton, different number of neutrons. Okay, so it is likely to be an isotope, but what is the definition of isotope? It's atoms of the same element with the same number of protons, different number of neutrons. So you have to make sure that they are atoms. Atoms meaning that same number of proton and electron. 1, 2, 3, 4, 5, 6. 6 electron, 6 proton. How about here? 1, 2, 3, 4, 5, 6. 6 electron, 6 proton. So both are atoms. So correct. So these two, they are related. They are actually isotopes. Okay, next one, show the physical properties of 3 substances. What are substances X, Y, and Z? Now, if you look at the first one, X, melting point, very high melting point, doesn't conduct electricity in solid state, soluble in water. So this is these are the properties of ionic compound. Okay, ionic compound, sodium chloride. Okay, and then graphite and diamond, you can refer to the textbook or the mind maps to see what are the properties of graphite and diamond in terms of solubility as well as electrical conductivity. Okay, the answer is C for number 7. Number 8, many chemical compounds contain ions. In which compound do both the ions have the same electron arrangement as argon? So first thing is you have to look it up in the periodic table. What is the electronic arrangement for argon? It is 2, 8, 8. So you have to look at the ions of this compound, and both of them must have the same electronic configuration as argon. So this one you can look at it, Ca2 plus, Br minus, this one will be K plus, S2 minus, and then just split them into its ions, and you should be able to find out that both potassium as well as sulfide ion has electronic configuration of 288. Okay, don't believe me, go and find out, look it up in the periodic table, write down the electronic configuration for all these ions. Okay, number 9, sodium and magnesium are next to each other in the periodic table. Okay, blah blah blah. Statement 1. Okay, what is correct about these two statements? Now the answer is actually B. Both statements are correct. Now let's look at it. Is it correct or not? Sodium has a low melting point. Magnesium has high melting point. Is it correct? Correct, because group 1 metals. Okay, group 1 metals, they have low melting point. Alright, they take out exposed to the air, and then they'll react with the moisture in the air. Alright, they have low melting point. How about the second statement? Ionic bonds formed by magnesium are stronger than those formed by sodium. Is it correct? So an example would be magnesium chloride. So magnesium chloride, Mg2 plus chloride, and then compared with Na plus Cl minus. So the ionic bonds is actually stronger. Why? Because the charge is higher. If the charge is higher, that means the electrostatic attraction forces would be stronger. So this one has stronger electrostatic attraction forces. Stronger electrostatic attraction forces between Mg2 plus and Cl minus compared to between Na plus and Cl minus, because the charge is higher. Okay, so both statements are correct, but statement 2 does not explain statement 1. Now this difference in ionic bonds, difference in strength or difference in the strength of electrostatic attraction forces between the ions does not explain the low or the high melting point of Mg as well as Na. Okay, so both statements are correct, but they don't explain each other. Okay, next one. The diagram shows a structural formula, covalent molecule fluoroethene. Consider all the electrons. Which description fits the arrangement of the electrons in the molecule? Okay, total number of electrons involved in bonding. So what is the meaning of one line? Okay, one line basically means what? Basically means share one pair of electron. So you have how many lines here? 1, 2, 3, 4, 5, 6. 6 lines. 6 lines meaning that it share 6 pairs of electron, which means 12 electrons. So the answer is either C or D. How about total number of electrons not involved in bonding? Now in this one, in this case, if you want to find out the total number of electrons involved in bonding or not involved in bonding, you have to draw out the dot and cross diagram, which is quite massive. So if you look at carbon, so carbon, right? Okay, you have something like that, and then hydrogen. Okay, look at, so I'm drawing this part, hydrogen, and then how about carbon and carbon? So carbon and carbon, they share how many? Okay, sorry, my drawing is not very good. They share 2 pairs of electron, which is 4 electron. Alright, then how about fluorine? Now fluorine, the electronic configuration is 2, 7. Now carbon is 2, 4. So 2, 7. So fluorine, okay, fluorine. So 1, 2, 3, 4, 5, 6. Okay, they share 1 pair of electron. Okay, and then hydrogen share again. I'm drawing this part. So something like that. Okay, so this is a dot and cross diagram. Okay, let me check whether it's correct or not. Yeah, correct. So it wants total number of electrons not involved in bonding. Not involved in bonding, that means not inside this intersection area. This is intersection area will be the electrons involved in bonding, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is this 12. Okay, how about not involved in bonding? The electrons not inside the intersection area. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, so this one, total not involved in bonding means not inside intersection area. Okay, count one more time again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12. So the answer is D. Okay. Now let's look at number 11. You have X2O. How many moles of X are combined with 8 grams of oxygen? First of all, what is the meaning of this X2O? You split it. Basically what it means is 2 mole of X, 1 mole of O. Alright, 2 mole of X, 1 mole of 2 mole of X combined with 1 mole of O. So which also means that this 1 mole of O is, what is the mass? Again, you look at the triangle. You have mass, mole, the AR or the MR. So in this case, I want to find the mass, right? So the mass is the number of mole times the AR. Number of mole is 1. What is the AR for oxygen? Look it up in the periodic table, 16. So 16 gram. 2 mole of X combined with 16 gram. Okay? 2 mole of X combined with 16 gram. This one. So what does the question want? How many mole of X are combined with 8 grams? So how about 8 grams? So what would be this number of moles? So this would be 2 times 16 over 8, which is A. Number 12. Okay, these two compounds are used as fertilizer. The proportion of nitrogen by mass. So you have to find out what is the proportion of nitrogen by mass. How do you find out the proportion of nitrogen by mass? Which is basically to add up all the AR. So in this case, you have 2 mole of nitrogen, right? So the AR would be 2 times nitrogen. The AR for nitrogen is 14 over the MR of the entire thing, which is carbon. Carbon is 12, oxygen is 16, and then 2 times 14 again, and then 4 times 1, because 4 hydrogen, multiply the 2 inside. So this one, if you use your calculator, you should be able to find how much? Sorry, I didn't calculate beforehand. $60. So you have 28 over 60. Okay, do the same thing for this, which is 2 times 14 again, because there are 2 nitrogen, and then 2 times 14 plus hydrogen, there are 4, plus 3 times 16. Yeah, so if this one, if you look it up, if you work it out, you should be able to find 28 over 80. Yeah. Okay, 28 over 60, 28 over 80. So which one is higher? This one is higher, right? So it's higher than, so it's either B or C. Now let's look at the second statement. Proportion of nitrogen by mole. So by mole is the same thing. How many mole of nitrogen? 2 mole. The rest, total mole, you have 1 mole, 1 mole. Hydrogen, how many mole? 4 mole. So 4, the total is 4 mole of hydrogen, 2 mole of nitrogen, 1 mole of oxygen, 1 mole of carbon. So total 4, 5, 6, 7, 8. What about this one? By mole. Same thing, nitrogen, you have 2 mole. Total 3, 4, 5, 6, 7, 8, 9. So which one is higher? 2 over 8 or 2 over 9 is bigger? 2 over 8 is bigger. So which means that the answer is C. Number 13, compound has empirical formula. Okay, what statement about this formula is correct? So XY2. XY2 basically means 1 mole of X combine with 2 mole of Y. You can also say 1 atom of X combined with 2 atoms of Y. Okay, you can also say, interpret it like this. So the answer is D. The ratio of X atoms to Y atoms is 1:2. 14. Blah, blah, blah. Okay, this one okay, fuel cell, actually you haven't learned yet. Hydrogen tank might split in the accident leading to explosion because your hydrogen is flammable. Okay, so this one is actually a basic knowledge. Hydrogen is flammable. So if it split during accident and with sparks, then there will be explosion. Number 15, molten calcium chloride. Okay, which statement describe what happened? This one also you have not learned yet. You have not learned this. Okay, how about number 16? Which change would happen at cell 1 but not in cell 2? Aqueous copper 2 sulfate. Aqueous copper 2 sulfate, you have hydrogen ion, you have Cu2 plus ion, and then OH minus ion and SO4 2 minus ion. So which N ion and which cation ion will discharge? The N ion that will discharge is OH minus. Sulfate and nitrate ion will never discharge. How about these two? So Cu2 plus will discharge. Alright? So Cu2 plus will discharge this is a cation, so it would discharge at the cathode, and this N ion will discharge at the anode. So when hydroxide ion discharges, it will form water and oxygen. So the answer is oxygen is given off at the anode. Let's look at number 17. Which carbonate gives a high yield of salt with dilute hydrochloric acid but not with dilute sulfuric acid? Okay, let's look at magnesium carbonate. With dilute hydrochloric acid, what does it give you? It gives you MgCl2. Okay, this is the salt, right? MgCl2. How about with sulfuric acid? So remember, acid and carbonate, you get salt and water and carbon dioxide. So sulfuric acid and magnesium carbonate, you get magnesium sulfate, and both are soluble. Okay, so you get both. The question is the question say not with dilute sulfuric acid, but with dilute sulfuric acid you will still get this salt. How about lead 2 carbonate? Now lead 2 carbonate with hydrochloric acid, you get PbCl2, which is insoluble. Which means that at the start when you mix hydrochloric acid to lead 2 carbonate, right? At the start, this PbCl2 will be produced. Now since it is insoluble, this insoluble layer of PbCl2 will prevent hydrochloric acid from further reaction with lead 2 carbonate. So you get a little bit of PbCl2. How about how about with sulfuric acid? Same thing, you get PbSO4, which is very little. This one is insoluble. Same thing, at first there will be reaction. After that, the reaction will stop because this insoluble layer of PbSO4 prevents further reaction between dilute sulfuric acid and lead 2 carbonate. Okay, so this one is not high yield already. With both the acid, not high yield. So B is not the answer because the question wants high yield with dilute hydrochloric acid but not with dilute sulfuric acid. Now how about barium carbonate? With dilute hydrochloric acid, you will get barium chloride, which is soluble. How about with sulfuric acid? You get barium sulfate, which is insoluble. Which means that the barium chloride yield would be very high, but the barium sulfate, the yield would be very low, because only at the start you will get barium sulfate. Then after that, there should not be any reaction between dilute sulfuric acid and barium carbonate because of this insoluble layer of barium sulfate. So the answer is C. Okay, so this one you have to look at the solubility of the salt. If it is insoluble, the yield will be very low because the reaction only exists at the start of the mixing. After that, the reaction will stop. If it is soluble, the yield will be higher because the reaction will proceed to completion. Okay, pure sample of barium sulfate be obtained from barium carbonate. Okay, so this one, the answer is B. Why? You dissolve it in dilute hydrochloric acid. So when you dissolve from barium carbonate, right? So you have to look at barium carbonate. Okay, barium carbonate plus hydrochloric acid. Again, it is acid and carbonate. So you get salt, water, and carbon dioxide. Now, this barium carbonate, it is soluble. If you mix with barium chloride, if you mix with sulfuric acid, what will happen? The sulfate ion and the barium ion will combine to form barium sulfate, which is insoluble. Yeah. Then after that, you have to filter it because this would be the residue, and then you have to wash it to remove any barium chloride as well as sulfuric acid that may still be with the salt. That may still be on the salt. Okay. So number 18, it is B. So you have to look at the ions. When barium and, this one, you can actually visualize it like this. When they are mixed together, right, you have Ba2 plus ion, you have Cl minus, you have H plus, you have SO4 2 minus. So the SO4 2 minus will combine with Ba2 plus to form barium sulfate because this is a precipitate, insoluble. So after they mix together, the next thing that will happen is the Ba2 plus and the SO4 2 minus, they will combine to form barium sulfate precipitate. Then what happened to the Cl minus and the H plus? They will just be floating around. Okay, they will just be floating around. These two, they combine to form precipitate. Number 19. How many reactions in the list? How many from the list form a gas? Does it form a gas? No. You have copper to sulfate and sodium carbonate. There is no gas. This is carbonate. If you have acid, then there will be a gas. How about this? Zinc oxide and sulfuric acid. You form a salt as well as water. So this one you get salt and water. Okay, this is amphoteric oxide and acid. Amphoteric oxide, it has both acidic and basic properties, so it will form salt and water. How about this? Now, what is this? This thing is ethanoic acid, which is basically the acid in the vinegar. Okay, it is a weak acid, the acid in the vinegar. So you have acid and metal, reactive metal. So you get salt and hydrogen. Okay, so this one, a gas is formed. How about this? This is sodium. This is water. Sodium dissolved in water, you get an alkali as well as hydrogen. Again, a gas is formed. So how many reactions? 2 reactions. So the answer is B. Number 20. Okay, you have aqueous zinc chloride. Zinc chloride has zinc ion, chloride ion. Form a white precipitate which dissolve when X is in excess. So this one is QA. This is a QA question. Form a white precipitate when dissolved, which dissolve when X. That means white precipitate is formed dissolved in excess. So your X must be form a white precipitate which dissolve when X is in excess. when X is in excess. Yeah, so your X must be aqueous ammonia. Okay, this must be aqueous ammonia. This one also, you have aluminium Al3 plus and sulfate ion, form a white precipitate which is insoluble. So this one is white precipitate insoluble in excess. Okay, so your X must be aqueous ammonia. So it is A. So look at your QA. Look at your QA. You'll be able to find out that zinc form white precipitate, dissolve in excess, and aluminium ion form white precipitate insoluble in excess. 21. Which of the following correctly shows the correct color changes? Now, solution in the flask. So this is titration, right? So this titration basically is like this. Okay, you have so this one, the answer is C, because solution in the flask you have NaOH here, and then you have HCl here. Okay, and the color change of promothymol blue, remember you have to put the indicator inside. Put the indicator, so the indicator must be put inside here. Indicator must be put inside. So the promothymol blue in sodium hydroxide, what color is it? Yellow. And then the color will change to red. Yellow to red. Okay, yellow to red. How about the other indicator, thymol blue? In NaOH, in alkali, the color is blue. Blue to yellow. Blue to yellow. Yellow, red, blue to yellow. So the answer is C. 22, the position of this one, okay. Which elements form oxides which can be used to safely neutralize acid? Oxides that can safely neutralize acid. What kind of oxide that react with acid? So this is basic oxide. Basic oxide reacts with acid. Amphoteric oxide also. Okay, so which one is basic oxide? Basic oxide would be non-metal oxide. Non-metal oxide. So this one is acid-bases chapter. Refer to your acid-bases chapter under types of oxide. Okay, under types of oxide. So basic oxide, basic oxide is metal oxide, not non-metal oxide. Okay, metal oxide. So for example, like sodium oxide, copper 2 oxide, all these are basic oxide. So it's metal oxide. So which are the metal? This one, what is this? This one, look it up in the periodic table. You can find out that it is copper. Yeah, so all these are metal oxide. This one is non-metal oxide. Okay, so the answer is D.